Hello everyone, and welcome to this first episode of Calculating Empirical Formulas. Today I'm going to be calculating the empirical formula of a compound that contains lead and oxygen. And I know that this compound is 86.6% lead and 13.4% oxygen. Let's start by answering a couple of questions. You might be sitting there thinking, well, we want to know what X and Y are. Can't I just go to the periodic table and find out what their charges are and balance the charges like we've been doing in the past? Well, if you thought that, congratulations, that is an excellent thought to go and use the tools that you have available. However, we have a problem here because if you go to the periodic table and look at lead to find out its charge, you'll note that lead actually has two possible charges, +2 and +4. So we're not told which one it is here, so we would just be guessing if we picked one of those and tried to balance the charge with oxygen. So we're not going to do that today. What we are going to do is calculate the empirical formula of this compound based on the amounts given. Now, the 4 steps for finding an empirical formula are always the same. The first step is to begin with the mass of each element in the compound. And you might be sitting there thinking, well, Mr. Rudolph, this is not a mass. This is a percent sign, not a gram sign. Is that going to be a problem for me? Well, yes and no. We do want to make it into grams, but it's actually super easy because we're not told how much of this sample we actually have. But what if I assume a 100-gram sample? If I assume a 100-gram sample and 86.6% of it is lead, then that means I will have 86.6 grams of lead. What's most important here is the ratio of the grams, and we're not changing that. It's really as simple as just crossing out the percent sign and changing it into grams. So if you are ever given percent signs, change them into grams right away. This information could be given to you in a word problem from a chemistry textbook or a worksheet, or it could be actually lab data that you went in and got in the laboratory. But regardless of where you get it, make sure it's grams. The second step is to convert it into moles. And in order to do that, you have to be armed with your periodic table, unless you have it all memorized, which would be, of course, very nerdy. So you would go to the periodic table and find the weight of 1 mole of lead and put it here on the bottom. So we're going to multiply by this conversion factor, 1 mole of lead, and on your periodic table you'll find that it will say 207.2 grams. We'll calculate that in a second. Going over to oxygen, which is at the top of the periodic table, you'll find that oxygen weighs 15.999 something grams, but I'm telling you right now, it's totally okay to just round that and just do 16. Keep things simple. Then we're going to do some math, and we'll find out that 86.6 divided by 207.2 gives me 0.418 moles of lead. And 13.4 divided by 16 gives me 0.837 moles of oxygen. So I've started with grams, changed it into moles. The third step is to divide these by the smaller one of the two. We want to make sure that these decimals get translated into whole number ratios. The easiest way to do that is to find the smallest answer, divide it by itself, and divide the other one by that number as well. This automatically becomes a 1, and when I calculate this divided by this, I get 2, and my calculator says it's pretty exact, 2.00. So suddenly, these very random, ugly looking numbers over here have been simplified into a simple 1:2 ratio, and my empirical formula is going to be PB1O2. And that is our empirical formula. So I hope this helped, and happy calculating. Bye.